Alright, hello guys. So yesterday we focused on the polygons and how, if you guys remember how 1 point doesn't create a polygon, like 1 point doesn't create a polygon, and 2 point doesn't create a polygon. We also talked about this equation for line segment, like for angles. This theorem is never possible, so never even try to do this, okay? So today we're going to focus on another part. Since we talked about polygons yesterday, today we're gonna talk about circles. Yesterday we learned why doesn't these create like these angles and everything. Today we're gonna talk about circles only. Why is this pi? So many of these. So if you know, we're also gonna talk about circles area. How can we discover with like normal way? Okay, circles. Let's get started. So I'm gonna draw like this shape in here. Okay. Now that's a good circle. Okay, so now this circle is 360 degrees. We always know that circles are always 360 degrees. If you guys didn't know about that, well, there you go. You just learned it, but if you did, I know it's a common fact. So just like I said, so why isn't this circle a polygon? I mean, it's a type of shape. I mean, but is it a type of polygon? Well, I'm gonna fact check it real quick. Yes, so circle is not a polygon, but it is a type of shape. Just gotta write shape in here. Good shape. Okay, so it is a type of shape. But why isn't it a type of polygon? If you remember what we did yesterday in the polygon, I'm going to scroll up. So remember how we talked about this part? Polygons require angles. They require angles. But does a circle have an angle? No. It also requires some line segments on this, kind of like that. Also, yeah, so like for this triangle, it has 3 lines. I'm sorry for drawing that. It has those. It has like some line segments, you can say. But this one is like really curved, and it doesn't have any single point. I mean, sure, you can do this point, this point, this point, this point, take this, and create a square. Okay, that could be one. But for a fact that I'm saying, that's just another way if you want to do it like that. But it's just circles always they're always curved. So remember, they are curved. And this is kind of where it gets tricky. If someone asked you, is circle a polygon? You're just gonna say no. I'm gonna write that. Wait, actually, I'm gonna use a different color for this. Gonna be big information. So, circles are not a polygon. Might say, why, Ratika? And again, I'm gonna tell you that circles are not a polygon because, as I told you, it needs like some sort of lines and it needs angles. But yeah, you're gonna say, isn't this whole thing 360 degrees? Yes, it's the whole thing, only one side are not polygons. Okay. Are not polygons. Remember that. I'm gonna wait. She's gonna square this a little bit. So kind of like oh, just it's not gonna work like that. Okay, so I'm just gonna go back to my red one. So they're not a polygon, and kind of like this. We'll need some. It will need more than 3 line segments. I mean, x has to be greater than equal to 3. Oopsie. To be a polygon. And circle is a curved thing and it doesn't have any lines. So it's never a polygon. Okay, so we got that basic part of about that circle. Now we're going to talk about pi. Okay, so what is pi? Well, pi was discovered by Euclid. Oopsies. Okay. Discovered by Euclid. So if you guys did Euclid geometry, it will make clear for you guys. So what is pi? There's some formulas for its area and perimeter, and we're gonna cover why does circles have perimeters and areas, and why does a curved shape have perimeters and areas. Okay, so it was discovered by Euclid, as you can see. But how can we discover pi? How can we discover pi? Well, I did watch some videos on how you can discover pi. So I'm gonna do it for you guys. So we're gonna do this. Make a really cool line. Okay, another one more circle. Nope. I'm gonna take this one. And that's good. No, it's not good. I want it to be perfect. I don't know why. I just want it to be perfect. Okay, I'm gonna take one more. That should do it. It's fine. It's just a little bit out. Okay, so in this drawing, you can see as this is a cup or a coffee cup, whatever you can just say it's a cup. So how can you discover pi with this? Well, we can use a ruler. A ruler is something that you can measure something with a ruler. So imagine this. We don't know the exact thing, so I'm just gonna I'm gonna pause this video. I'm gonna try to come back with a ruler and see if I can measure it, so you guys can come back with it too. Alright, I came back with a ruler. Let's see if I could measure it out. Kind of like let's say like a wooden ruler will help be in some inches or so. Kind of gonna be right there, so one inch is how many centimeters? Let's say we're gonna. I don't memorize these. 2 centimeters. 2.54 centimeters. Okay. So this upper part it has a diameter, okay? So it's D equals to 2.54, and its lower D has kind of right here. No, actually this wasn't. This one is 2.54. This one is 2.54. And that one I would say will be kind of like 0.75 and a half, so 0.75 and a half. Kind of like said 75 and a half. So I cannot do more than this, but when I'll tell you that if you have a centimeter ruler, you can measure these out. Then you're gonna measure the circumference of this whole thing. And when you measure the circumference, you're gonna do like some of kind of like a slope intercept way. You're gonna do y2. Why do I keep making mistakes? Okay. y2 minus y1 divided by x2 minus x1. Gonna write in the slope intercept. After this, you're gonna find out pi, then which is m. So if you guys know, in the y-intercept form, it is y equals to mx plus b. On this one, you're gonna write for m. You're gonna write pi, and you're gonna write pi and the diameter pi d or plus 0 c. So what is d to r? And you find it right. Circumference is 2 pi r. Whoa. We found it. Hey, mate. We found this whole thing by ourselves. So that's gonna be the way you guys are gonna do it. Just gonna erase these whole things because we don't need it anymore. Erase the beautiful cup too. Now that we demonstrated an example for you guys, I'm gonna talk about what is pi actually and how can you use it. So like I said earlier, pi was discovered by Euclid. And Euclid found measured it approximately out. So pi is, if you measure it approximately out, it's 3.1415. So pi is 3.1415. Okay. So since pi is 3.1415, we can measure the area of a circle. So I'm going to take a circle. Okay, we're going to keep writing. So this circle has an area of pi r squared. Now we're going to, so I'm going to write the formula. So this is the area, so I'm going to arrow mark it. A. And it also has perimeter, which is 2 pi r, the one we discovered with the slope-intercept form. So now we're going to talk about, hey, why does curved shapes like a circle? So why does curved shapes like a circle have areas? Like, what is inside of them? Wait, I did that whole thing wrong. Wait. Okay. So this, wait, my God. Okay. So this is a circle. And like I said, it's a shape, not a polygon. In this shape, there's an interior area, just like you would say for a square or a rectangle for now. This, let me see, I have minimum amount of colors. So this square has some sort of area inside, and you can also measure the outside. So just like a square, just like a square, a circle also has an interior area and an exterior area. So any shape of any kind always have an area I wrote it wrong, but it's okay. So as an area and as a perimeter. Yeah, whatever. Just gonna. So as you can see, like that, we're gonna talk about circle theorems and how you can measure the other parts later in this video. But for now, you guys learned any kind of shape has any kind of area. So let's calculate. So this is going to be like a sample example. Yes, sample example. Sample example of a circle. So I'm going to draw a line. Perfect line. Wow, that was really good. And you're going to draw like a small circle. Just as the center point. That looks like a Pokeball right now, but yeah, it's fine. So this whole thing, let's just say this whole thing has a diameter, to keep it simple for now, has a diameter of 10 centimeters. And what is the radius then? Well, the radius is the half of a diameter. So the radius, how you calculate that is the diameter divided by 2. And then if you cross multiply, it'll be 2r equals to the diameter. In this case, if we, oh god, wait. In this case, if we plug in this case, if we plug in 10 for the diameter, and why does it get stuck? If we plug in 10 for the diameter, then how much will be r? divide 2 on both sides, or will come out as 5. So the radius was 5. Just going to go. So the radius will be 5. So now, what is the area and what is the perimeter? For the R, we're gonna plug in 5, so it will be 25 times 3.1415. I'm just gonna keep it simple for right now. The area is 25 pi. And what is the perimeter? Well, what is 2 times R? 10, and keep it simple for right now. 10 pi is the perimeter. So just like that, we found how to calculate the circle's area and perimeter. Now we're going to scroll down and talk about some circle theorems. So just going to drag and drop. Three circles. And we're going to do the theorems. So what is, before we go to the theorems, I want to talk about the semicircle and the quarter circle perimeter and area. So I'm going to divide the circle in half. And now to go. You know what? I can actually delete this. Okay. So what do we call a circle that is broken into half? We call it a semicircle. So semicircle, write it like this. Semicircle. And how do we find the perimeter and the area of it? For the perimeter, it has a formula, which I'm going to go over with you guys. But for the area, it's super easy. You're just going to take the area of this whole thing, pi r squared, and since it's broken into half, just divide it by 2. And voila, you get the area of a semicircle. But what is the perimeter, like I discussed? Well, the perimeter has a formula, and it is pi r plus 2r. But is it the same as 2 pi r divided by 2? Well, I wouldn't say it's exactly though. Even though you can find it like that, it's not exactly like that. So this is pi r divided by 2 is the perimeter. So just like last time, if we plug in 5 for each, this will be 25 pi divided by 2. This will be 12.5 pi. So area would be 12.5 pi. And the area would be, well, 5 pi plus 10. So we 5 pi plus 10 as a expression. Okay. 5 pi. So now let's talk about a quarter circle. So I took a lot of time with this. So I'm just going to scroll over this. I'm gonna actually take this. No. I'm gonna. Man, how can I drag and drop? Oh god. Cancel. Yeah, finally. Man, what the heck? Okay, gonna bring that over there. There. Then I'm gonna scroll to this side. Grab the circle, go over there. Even go over there. Okay. Now we can grab these. Gonna separate that to that way. Just like that. Okay. So let's talk about the area and the perimeter of a quarter circle. So like 1/4 of this. So what is the area of the quarter circle? Well, just like I said about the area of the semicircle, since it's divided into 4 parts, you write the formula of a normal circle and then you divide that by 4. So this is it. Okay? So far so good. Man, what the heck? Okay, I'm just gonna drag and drop. Going to. Ah, my god. Okay, now this should be good. Yep, it is good. So this will be the area. But this one doesn't have a formula for the perimeter. I believe so. So it'll be 2 pi r divided by 4. Just like last time, if you plug in. So just like last time, if we plug in 5 for radius, we will get, for the area, we will get, 5 squares, 25 pi divided by 4. Well, it would be, let me check. Stupid. It will be 6.25 pi. So approximately about 6 pi. And for the perimeter, it would be well, for the perimeter, it will be 10 pi divided by 4, which will be 2.25 pi. So just like that, if you want to find, man, why did that happen? So let me just draw the circle again with the line, another line. So just like that, if you want to find 1/4 of it, it will be like that. Alright, now let's talk about some circle theorems. And for the circle theorems, it has to be in a coordinate plane. So coordinate plane, you stretch that all the way down. Then another one, you stretch that. Like that. And use a different color. Choose red. No. I want this to be green. That's it. Now for the writing, I'm gonna write this. Now look. 1, 2, 3. Now it's gonna take me forever. So instead, I'm just gonna, just gonna draw it.
Bumpy.
So let's draw a circle. So we're gonna draw a line, basically, on the circle. So a line, which sounds like a hypotenuse of a right triangle. Now we're gonna draw another line. And then another line. I don't think this was accurate, so I'm just going to wait. So I'm gonna delete. Wait, it has to be kind of like perfect if I want to show it to you guys. Because as you guys know, I'm gonna make it go like. Why do I keep messing up? Okay, let me draw a perfect circle with the line that stretches from here, line that comes down from. Man, why do I keep that? Oopsie, sorry. Got like a burp. Okay, circle again. And then another one comes. Okay. Yeah. Okay. So basically, we want to find the center of the circle, and also we can also find the radius, which is kind of like this one would be like the hypotenuse. So like this point to this point. So let's say this point is about cross this point is about 5'2", let's say. Five, 2, and this point is about, let's say, 9, 6, let's say. Just making these numbers up, so remember, they are not correct. Just making these up. So what will be this thing? Well, obviously we're gonna do this thing again. We're just gonna measure this out. Well, if you want to try to find the center, this will, so let's just do this 9-1 or 9-2. Let's find the center of this one. So the formula for this circle theorem is x minus y squared, and kind of like that. But for this one, we'll discuss about this later in this like course of playlist. For now, you remember this is the circle theorem. Well, to be honest, I have to kind of do a little bit of research. I did do this some practice with my mom, but still, just kind of have to make it in this. I kind of like forgot this, but I'll still research it and I will help you guys tomorrow. So, thank you for watching for this much long. I hope you guys feel good. Not like feel good, like what would I say? Stay safe, stay healthy, and we'll catch on to you guys next time. Bye bye.